Okay, this time we're going to be evaluating a composition of trigonometric functions and inverse trigonometric functions. So it's important to note on each one of these, we have an inverse function on the inside, and it's not sine and sine inverse. So we can't get any nice canceling out going. So whenever we have an inverse function on the inside, and it's not the exact same, what I always like to do is we're going to draw a triangle and use a let statement. So the let statement is just, we're defining a variable. So in this case, I'm going to say theta is going to be whatever the inner function is. So in our case, cosine inverse of 4/5. All right, what that allows us to do is, first of all, we can rewrite this. All we're trying to do is we're trying to find the sine of, replace all of this inner part, the cosine inverse of 4/5 with theta. That's what we defined it to be. The next thing we can do is we can rewrite this equation that we just created, the theta equals cosine inverse of 4/5. What this tells us is we can also apply a cosine to each side and say, well, cosine of theta is going to equal cosine of cosine inverse of 4/5. It's going to equal 4/5. So now we have an equation that involves cosine instead of cosine inverse. From here, what I'm going to do is suggest that we draw a quick triangle to go along with our situation here. We know we can draw a right triangle because we have a trigonometric function and ratio. I'm going to place theta in this bottom left-hand corner. By sohcahtoa, I know that cosine is adjacent, so I can put the 4 at the bottom over the hypotenuse. So adjacent over hypotenuse based on sohcahtoa. And I am trying to use this triangle and find sine of theta. Well, I know sine of theta is reliant on the opposite side length over the hypotenuse. So we already know the hypotenuse. I can put 5 down here in the denominator. We have to do a little bit of work and find the opposite side length. So this opposite side length, I'm just going to call it b for right now. We can use the Pythagorean theorem and say, well, a squared plus b squared equals c squared, where c is always the hypotenuse. So let me see, we have 16 plus b squared equals 25. I'm going to isolate the b squared by subtracting the 16, moving it to the other side. Then we're going to apply the square root to both sides to get b on one side by itself. We get 3 on this opposite side length. All right, now that we found that, I'm going to go ahead and just plug in our opposite side up here. And now we've evaluated it. So our overall exact value is going to be 3/5. All right, hope this helps. Good luck on these. Not that bad, but a little bit different as far as how to get started on them and drawing the triangle from some other problems. So good luck.